Hello everyone, this is Yetish Narayana here. Today I'm going to talk about Apache Tez. Tez in Hindi means speed. We'll talk about an overview, architecture, benefits, performance, and Tez data API. We also have a demo application, two demo application, movie database, and citations big script. Tez is a framework for building high-performance batch and interactive processing applications. It is built on top of Yarn, so it enhances the existing MapReduce framework by improving speed. So existing MapReduce, Pig, and Hive process can use Tez without any modification to their code. The basic idea being Tez was built on top of Yarn, so they can utilize the existing framework. Main benefits of Tez include increase in performance, reduce load on HDFS file system, a couple of more. The reduction in load on HDFS file system is due to the fact that Tez has eliminated the I/O synchronization barrier. Basically, all read operations to the HDFS file system between MapReduce jobs have been eliminated, and this is what has been depicted in this image. Tez introduces data API, wherein it models the data processing as a data flow graph with vertices representing processing, and the edges represents the movement of data. So a DAG defines an overall job as part in an data flow graph. A vertex defines the user logic, and an edge defines the connection between a producer and a consumer. Let's jump into the demo. So I have developed a movie database application, a Java application, MapReduce one, which basically computes the average user rating for a particular movie. The data set that I used for this particular application is about 500 MB in size. But for our demo purpose and in the interest of time, I've reduced that data set to I guess it's almost about an MB, I guess, to make sure we show the full demo. So let's jump to the demo. Okay, let's go to the workspace. And we have the jar here. Yes, we do have the jar here. Let's see what all we should be doing beforehand before we move into, yes, we now here. So there is no configuration change required because we are executing it in the Yarn mode. So I'll directly go ahead and execute the service C. Okay. I'm just making sure there's no output HDFS output folder in the system so that it doesn't throw an exception. Let's execute the job. So movie in one is an HDFS file input system. If you observe here, it is actually initializing the Yarn client. So later on I'll show that it will initialize a Tez client. So movie underscore in one and movie underscore in two have the two input files, input folders, HDFS input folders. One will have a ratings.csv file, and the other has a movies.csv file. So it is so our MapReduce job is still executing. Let me show the data set that I've used for this purpose. A trim data set would actually make sense. Let me open the file if I have. So this is one of the folder, file ratings.csv. Basically, the header states that the structure of this file content is user ID. First column is user ID, next is movie ID, rating, and then timestamp. If we see our movies CSV file, it is like movie ID, title, and genre. So this map reduce job, what it does is it combines the data that is there in these two CSV files, eventually arriving at a movie and the average user rating for that movie. Now let's go back and see if the job is completed. Yes, the job is completed. Let's see how long it took to execute. Okay, it started at about 1833 and it took about 1834. So I would say about 1 minute, 1 minute 10 seconds. Now let's change to yarn mode. Now how do we do that? We need to edit the map red site config XML and change an entry for the framework. Let's do that. Let's give the root password. Okay, here we are. So if you see the MapReduce framework mentions it to be yarn, we will change it to yarn tails. Now let's save the file. So this is done. Now for this changes to take effect, we need to stop and start the HDFS services. Now let's use this command to stop the existing services. So it is stopping the data node. Hadoop data node is stopped. It's now attempting to stop the name node. Name node stopped. Attempting to stop the secondary name node, and that is also stopped. So we have stopped the services. Now let's start them. Okay, trying to start the data node. I guess it takes some time to start. Okay, data node started. Name node, attempting to start name node. Name node started. It's now trying to start the secondary name node. Okay, all services are started. Now let's try and execute the service again. Now let's make sure there's no output folder. Okay, so if you see the for some reason the name node is in safe mode. I usually observed when we stop and start the service, it goes into a safe mode. I haven't really gone much deep into why it is going, but let's come out of the safe mode. Use this command. Okay, we have come out of safe mode. Now let's remove the HDFS folder, output folder. Okay, remove successful. Now let's execute the job. Okay. So previously it took about 1 minute 10 seconds. Let's see how fast this executes in tails. So if you see, we can observe here the client that is getting initialized is a tails client and not a yarn client. Okay. Okay, I'm still waiting. So the job started to execute in about where was that? Here, yeah. So 1838 too. Okay, and it's still 1838 and it took about 35 to 36 seconds to complete. So as and when the size of the data set increases, we can see a considerable improve in performance. Now let's before we go ahead and demo the uh, um, let's do this thing. Let's go back to our slide. Go back to our slide and see what was it that we encountered earlier. So as part of the original data set, it took about 7 minutes with yarn for it to execute, and we didn't see the output, so let's go back and examine the output. Go back and examine the output. Most of the user rating will be 0, 0 because of the trimmed data set. I didn't take much care in trying to see all movies were taken into consideration. So let's leave it at that and move back to our slide. And yeah, so here is the actual output that we would see if we use the full data set. Okay, this is what we changed from yarn to yarn taste. We start the services and the with original data set with and executed using taste framework. The job was executed well within 4 minutes. Now let's demo our citations, but before we do that, let's change back our map red site map, the changes that we did to our map config file. Let's go back and change this. I want to make sure that it executes in yarn mode and not in map reduce mode and not in taste mode. So changed. Let's save this. Okay, now again we have to repeat the same process of stopping and starting the services. Let's do that. So we have the data node stopped and name node stopped. Yes, and we have all nodes stopped. So let's now start it. Yeah, I've tried to have all commands under one uh, file. Usually it's the best approach would be to actually put this into a shell script and then run. But for simplicity's sake and for the demo purpose, I'm just keeping it separate. Okay, we have okay, all services are started. So again, it will be in safe mode. So let me make sure I execute this command so that we come out of safe mode. Okay, we have come out of safe mode. Now let's execute our citations pig script. Now this script is nothing but a collection of um, uh, scripts that we developed as part of our assignment 7 solution. So there's nothing new about it. Oh, that was very quick, very quick. Okay, does not exist. Okay, I'm in a wrong location. My bad. So let's move to the right location. Do I have the citation speak? Yes, I have it. Now let's execute. Yes. Okay, the execution type is MapReduce, and that's what we are seeing here. Let's see how much time it takes. Once the script ends, it actually gives out the information of how much time it took to execute, so we can clearly know how much time it took. The data set again that I'm using for citations has been trimmed for demo purpose. So let's see how much time a trimmed data set would take. My best guess is it's about 1 minute, I guess. Let's see. Okay, 16% complete. So as this executes, let's go back to jump to our slide and see how much time it took with our original data set. With the original data set, where was my, here it is, yes. Okay, with the original data set, the time it took was about 5 minutes and 30 seconds. 5 minutes and 30 seconds. This could actually be even more higher. The reason being that I believe my map red config file still had a setting of um, yarn these. So I'm not sure about that, but based on time constraint, I don't want to go back and then do it. But yeah, so citations were executed in Tase mode. So earlier it took about 5 minutes 30 seconds. With Tase mode, it is took about 4 minutes 13 seconds. So let's jump back and see if we have any output here. Oh my God, it's still taking time. That's okay. Let's wait it out. 50%, 55%. Okay. I have about 20,000 records that has been used for this purpose. So I guess it's not much for a MapReduce application, but I guess this pig script is quite exhaustive. What we are doing here is that we first collect uh, the patents that have been cited, and once we get that, we then count the number of patents that are citing this particular patent, the cited patent, and then once we have that, we count the number of patents that are cited count number of times. So basically we are kind of building an histogram. So a collection of 3 to 4 pig scripts have been combined into one and then being executed here. That's the reason we're seeing a bit of consumption in time. Okay, it's about 83%, 88% complete. Okay, I guess we should be good. Let's hope so. Okay. Let's jump back to the slide and see if we missed out mentioning anything. Okay, finally, the pig script completed in about 3 minutes 58 seconds. Okay, excellent. Now what we'll do is that we will execute the same pig script in Tase mode. Now for sure this will take very less time, but how much less time? Let's see about that. Here we are. Let's go. You can see here the mode that has been picked is Tase mode. This is quite fast. It's like yes, fast. This is fast. Okay. Yes. So we are good here. And let's see. The big script actually completed in 34 seconds. Wow. So from 3 minutes to 34 seconds. So we have seen a considerable change in time here. Considerable improvement. That's excellent. So let's go back here and see. Okay, perfect. That's about it. Thanks for watching the presentation. Let me know what questions you have, and I shall get back to you through the forum. Thank you and have a wonderful day.